Okay, so this is the final problem that we have. And after this one, I think you should have a pretty good understanding of what the concept of marginalism means and how that guides economic thinking. And so here we have a situation where we have a profit maximizing problem. And so we have a total cost function, and you know a total cost function is typically inversely S-shaped. So it should look something like this. Okay, so let's make that straight. Okay. Okay, so we have here our X, and then here our total cost. And you see here we have the 2, that's the fixed cost, so there's a fixed cost part, maybe here. So that's the fixed cost. And then on top of it we have our inversely S-shaped production function. So it looks maybe something like this. Well, maybe that's a little bit too extreme. Let's do it again. Okay, let's try it again. Looks like my okay, maybe that looks a little bit better. So this is what a typical cost function looks like. And then we have a total revenue function. So our total revenue function is just a straight line, 3x. Maybe I give that in a different color, maybe total revenue may be green. And okay, so total revenue is a straight line. Okay, so total revenue is this, and then we have our total cost function, which is the black one. Okay, so now we see that so what is the profit function? The total profit function is total revenue minus total cost. So in economics we like to abbreviate profit with the Greek letter for pi, or the Greek letter pi for profit. So the total revenue is simply 3x minus, and now we subtract the total revenue, which is minus 0.1 x cubed minus 1.5 x squared plus 8x plus 2. Or if we want to get rid of those parentheses, we can say this is equal to 3x minus 0.1 x cubed, minus times minus is plus, plus 1.5 x squared, minus times plus is minus, negative, minus 8x, and minus 2. Okay, so that would be the profit function. Okay, so what's interesting now is, we see that there is a part where the total revenue, the green one, is less than the total cost. So this black one is total cost. Actually, okay, so we have here total cost, the black line, and there is this range where here the total cost is greater than the revenue. So obviously we first make a loss. So typical profit function. So if we have here the profit, the pi, and here x. So you see there is initially we make a loss, and the loss gets bigger and bigger, but then the total revenue catch up to the total cost, and then there's a point where we break even. So here's the break-even point. So the total profit function looks something like this. Initially, we make a loss, but then total revenue catches up with the total cost, and then we start making a profit, and there must be somewhere a maximum, but then we would make again a loss. Okay, so but now we can see that there are like two situations where we have here the slope of the profit function is 0, so that's a minimum, and there is the maximum. Okay, so now we want to find where is the maximum, and we still can take the derivative, and we have to find the optimum solution, which is where the marginal profit is 0, but we need to be careful and see that there must be two, that we have possibly two solutions, and one is actually a bad one, because if we got this solution, that would be, you know, like the maximum loss. So we are obviously trying to find that x star, not this value, because that will give us, that's a minimum, so that's you know, that is definitely the one that we don't want to find. We will find it, but we need to know we have two solutions. Okay, so let's take a look at this profit function and draw it in Excel. So I can go back to Excel, and I still have here from the previous example the x-axis with the step value of 0.1, and there's still something here that I can delete. Okay, let's quickly do here something. Review. Okay, don't know why. Maybe now I can delete it. Yeah. Okay, so now the profit function is 3x, so equals 3 times x minus 0.1 times x cubed plus 1.5 times x minus 8 times x minus 2. Okay, so that makes sense if I don't have any output. The only cost that I have is the fixed cost of -2. I have no revenue, so I make a loss of -2. Okay, now let's copy this down. And now let's take a look at what this function looks like. So it should something like the lower panel here. So let's go Insert, Recommended Chart, and it looks like I made somewhere a mistake, that can't be right, so I must have done a mistake. Let's double check again. Okay, so the total revenue is equal to 3 times x, and then minus, okay, let's do it this time, 0.1 times x cubed, and then minus 1.5 times x squared plus 8 times x plus 2. Okay, now let's see if we get something that looks a little bit better. And yeah, there's a small, I must have made somewhere a mistake. So this is the function that we should get. So this is the correct graph, similar to the one that we could derive from sketching those functions. So okay, there's minimum here, so there's the slope at the value of maybe, I don't know, 2.2 or so. So like here, at 2.1, maybe we have a minimum, but this is not the minimum or the value that we've tried to find. And at around 8, there is a maximum. So we need to find the 8. Okay, so derive the approximizing level. Actually, B, draw the profit function into the Excel function. Okay, we did that. So now derive the profit maximizing level of production. Okay, so that's maybe here. So it's around 7.9 if we just do it graphically. So let's do it like this. So the optimum X is around 7.9. And actually, to be more accurate, whenever we think it's close to the optimum, but it's not really the optimum, we take those wiggly lines instead of the straight ones. So it's around 7.9. Okay, so next one is, what is the derivative of the function? Okay, so let me actually see, what did I do wrong here? Actually, I can't see anything. So the derivative should be, okay, so the derivative of the total profit function is d pi with respect to dx. Okay, so that should be 3. Okay, minus 3 times goes in front, so minus 0.3 x, and now we have to subtract the 1, so we are left with a 2, plus 1. So the 2 goes in front, so 2 times 1.5, so plus 3 times x, so now there's technically an invisible 1, 2 minus 1, then minus x, minus 8 times x, the derivative is minus 8. Okay, we don't have to worry about the negative 2, because there's no x, so when we derive it, it just disappears, it's a constant. Okay, so now we have basically here a 3 and here minus 8. We can actually simplify that to minus 0.3 times x squared plus 3x. And then if we subtract from the 3 the minus 8, we have here still minus 5. Okay, so that would be the marginal profit function. And so now we could solve it manually. There is something which is called the quadratic formula. We could use this one, but it's not a class in math. But the emphasis is on teaching you certain skills beyond math. So, okay, so this is the first derivative of the production function. And in order to find the optimum value, which could be this one or that one, I need to set it equal to 0. Okay, again, we could solve this manually. It's a quadratic equation. Just for completion, the quadratic formula is x12 equals, maybe you have seen this, minus b plus minus b squared minus 4ac divided by 2a. And in this case, the negative 0.3 would be the a, this 3 would be the b, and the constant of negative 5 would be c. So if I could plug in those values here, and then I would get 2 results. one of which is the optimum here. But we don't use Excel, we don't solve it manually, but we want to use GoalSeek. So let's open Excel again, and we can just go to any value, any cell. So let's say here is X, and I just plug in now 1. And now the result has to be equal to, okay, so negative 0.3 times X squared plus 3 times X minus 5. Okay, so in this case, if the value is 1, I get the value of negative 2.3. And now I can just play around with other values manually. Let's say I plug in 2. Okay, that's actually close to 0. So the slope is actually close to 0. And when we looked at it, we thought maybe it's 2.1. Okay, so it's around there where the slope is 0, but at around 2.1 it is this value, right? So here it's around, there would be a negative value. So there must be another point where the slope is 0, but it's further up, maybe at 10. Okay, now let's see what happens if I go down, maybe 9. Let's take a look at the graph. So it looks around maybe 7.9. So let's say I try 7.9. Yeah, it's probably close. It's around there. Okay, but normally you don't want to, manually play around with those values until you find which value is the best, or but the optimum solution is, but you want Excel to find it for you. So we go to data, what if analysis, and then we go to GoalSeek. Okay, we want to say set the cell, which is the result, which is in this case the cell E111, to the value of 0 by changing this cell. Okay, let's do that. Okay, so the best result that we get is 7.88, which is close to the 7.9 that we got. But now see what happens. Let's say if the initial value would have been 1, right? And now I go again to GoalSeek. So data, what if, GoalSeek, and I want to set the cell E111 to the value of 0 by changing this one. You see, now it finds the first value, 2.11. So that would be, however, the minimum. And since the initial value was 1, it was going up. And so Excel tried 1, 1.1, 1.2, 1.3, and then at 2.11 it realized, oops, that's the best value. But of course that can be misleading because that's not the maximum, that's in fact the minimum. So now if I want to make sure that I get the maximum, I have to start with a value which is very high. So let's say I add here 1,000. Okay, so now Excel starts at a very high value and goes down. So now let's see what happens. So we go data, what if analysis, GoalSeek, and we want to set our result cell to a value of 0 by changing X. And then we just say OK. And then you see, because we force Excel to start from the right, the first value that it hits is now actually the maximum, which is 7.88, or if we just limit it to decimals, 7.89. Okay, so in this case, set the marginal function and solve using, okay, so the optimum value is around, what did I say, 7.8, let's say 7.9. Okay, and the final question, how big is the maximum profit? So we can look that up again. Now in our profit function, so we just go to 7.9 and we see that the optimum profit is around 2.81. So now we have here our result, optimum profit. Okay, so optimum profit is around 2.81. Was that correct? Yeah. Okay. So I hope that you have an idea now of how that whole concept of marginalism works, and you get a little bit of feeling for Excel, and you see how that is useful to solve certain problems. And yeah, I'll just stop here. I hope you enjoy working a little bit on such kinds of problems, and you can already anticipate maybe some real-world applications for that as well. Okay, I'll just stop here. So thanks a lot for watching all those videos. I hope it wasn't too boring. And yeah, I'll see you in class. Thanks a lot.